Good afternoon, class. We are looking at Chapter 8, Analytic Geometry. Here's Section 8.0, Circles. We are going to cover the circles, the ellipse, the hyperbola, the parabolas, and the objectives for this section is to determine general and standard form of equation of the circle, graph circles with centers at the origin, determine general and standard form of equation of the circle given some geometric conditions, convert general form to standard form of equation of the circle, and vice versa. Recall, we were solving it by graphing, substitution, and addition, and other methodologies for systems. A system of two linear equations in two variables can have one solution, no solution, or infinite number of solutions. A consistent system with independent, the system has a single solution at the point of intersection. The graphs are different, they have different slopes. In this case, in consistent system, the system has no solution. The graphs are parallel lines. They have the same slope, but different y-intercepts. Consistent system with dependent equations. The system has an infinite number of solutions. The graphs are identical. They have the same slope and the same y-intercept. The graphs are identical. There are an infinite number of solutions. Matrices and matrix operations. Matrices are classified by their dimension, the number of rows and columns. A matrix with m rows and n columns has dimension m by n. A square matrix has the same number of rows as columns. The dimension of a square matrix is n by n. A matrix with only 0 elements is called a zero matrix. The elements of a matrix minus A are the additive inverse of the elements of matrix A, or the opposite. And for example, this one has 1 and 2 rows, 1, 2, 3 columns. It's a 2 by 3 matrix. The operation, algebraic operations that we do on numbers, we can do for matrices. Some of them, such as a 0, when we add 0, we get the same. Of course, this is not a 0 number, rather it's a 0 matrix. We get the same matrix. If we add A to its opposite, we get 0. A plus B is the same as B plus A. A plus B plus C is A plus B plus C in any order. Commutative property and associative property for addition works. Also, summary of matrix addition or subtraction. If A and B are both m by n matrices, then the sum of A and B, that means A plus B, is the matrix obtained by adding corresponding entries of A and B. The difference of A and B, A minus B, is obtained by subtracting corresponding entries of A and B. Solving system with Gaussian elimination. Matrices and technology. Matrix methods enable calculators and computers to efficiently handle and solve large systems of equations. Matrix row transformation. Efficient implementation of echelon method. Here's a system. Here's the first equation, second, third, and here's the augmented matrix. A1, A2, A3 if you look at the column, A1, B1, C1, D1 if you look at the rows and columns. So this is called an augmented matrix, where each member of the array is called an element or entry. The rows of an augmented matrix can be treated just like the equation of a linear system. Simply put, you just use the coefficients and put them here. So in this case, this is called the coefficient matrix. And this is the last column called the constant or solution matrix. Also known as the solution matrix. The determinant of a 2 by 2 matrix is just a cross product. So if this is the matrix, its determinant uses like an absolute value, and it's the cross product AD minus BC. That's the way it looks like, everybody. Pretty straightforward. So if this is the matrix, this represents the matrix A. Let's say this represents its determinant. Kramer's rule for two equations containing two variables. The solution to the system ax plus by equals c, cx plus dy equals d is given as follows. Now, first and foremost, it's important that we understand D is the coefficient matrix ABCD, and you calculate the determinant of that. Now, note, we replace the first column of D by the solution matrix for D sub x. So we put S and T for the first column if we are solving for x, and we replace the second column, this column of a D, by this solution matrix D sub y. Notice over here. So this one is the denominator of D. You put the same thing at top. The first column is changed to S and T for x. The second column is changed to S and T to solve for y. So x is dx over d, and y is d sub y over d. So that's the synopsis of what we have covered. And now let's look at this section. To do so, first, let's discuss the concept, identify and describe the conic section. Conic section, a curve in a plane that is the result of intersecting the plane with a cone. Here's a right circular cone. You have two of them inverted. So as we have a line, if we have a line and there is a line crossing it, as it revolves around it, it creates the two. When we cut this, types of conic sections include parabolas, circles, ellipses, and hyperbolas. When we cut this with a plane, it creates the following. If we cut it in this format, let's start with this one, perpendicular to the axis. This is the axis. If we cut it with a plane perpendicular to the axis, we get a circle. If it's tilted, it creates an ellipse. If it's tilted and it goes through one opening, it gives us a parabola. And if it's parallel to the axis, creates a hyperbola. That's how they are created. So the first conic section we want to look at is circle. So let's look at circles. A circle has a specific definition. A circle is the set of points in a plane that are the same distance, called the radius, from a fixed point called the center. Circle with its center at the origin and radius r has this equation, x squared plus y squared equals r squared. And it has got to do with understanding the distance formula. If you have this point with coordinates x and y, and you want to find the distance from the center, which is 0, 0, x minus 0 quantity squared plus y minus 0 quantity squared, under the radical gives us the distance. This distance, we call it radius, and therefore x squared plus y squared equals r squared. Also, you can look at it from the point of view of Pythagorean theorem. This distance is x, this distance is y, so x squared plus y squared is r squared, or r is the square root of x squared plus y squared. Circle with its center at H and K. If it's not centered at the origin with the radius R, if X and Y is a point on the circle, then by definition of a circle and the distance formula, it follows that R is square root of X minus H quantity squared plus Y minus K quantity squared. Squaring both sides give the equation in standard form, X minus H quantity squared plus Y minus K quantity squared equals R squared. So if it's centered somewhere else, you go with the distance formula, and believe it or not, that's a proof. Let's look at this one more time. So this is a circle centered at 0, 0. This is some point on the circle having coordinates X and Y. This distance is X, this distance is Y. Remember, this is X. It's the same as this one. And so X squared plus Y squared is R squared. You look at this one, you go with the distance formula, X minus H quantity squared plus Y minus K quantity squared should be R squared. So that results in what we are looking for. The distance formula does that. Very straightforward, everybody. All right, graph the circle X squared plus Y squared equals 16. So we have X squared plus Y squared equals R squared centered at 0, 0, and the radius is square root of 16 or 4. So we have the center. And then because the radius is 4, we have 4 points, 4, 0, negative 4, 0, 0, 4, 0, negative 4. So these are the 4 points. 4, 0, negative 4, 0, 0, 4, 0, negative 4, and that's a circle, and you're done. In this case, X squared plus Y squared equals 10. Again, we have the same center, but the radius is square root of 10, and square root of 10 is about 3.16. So you do the same thing. Here's the center. 3.16 is roughly here. So you have 1 point here, 1 point here, 1 point here, 1 point here. Put them together, and it looks like this. Determine the equation of a circle shown below. Well, we notice the center is at negative 3, 2. And we pick 1 point clearly, this is 0, 2. So that tells us the center is negative 3, 2, and the distance from here to here is 3, which makes the radius 3. So the center located at negative 3, 2, and the radius is equal to 2. I hope it's clear to everybody. So what happens? X minus H quantity squared plus Y minus K quantity squared. So X minus negative 3, which makes it plus 3, and Y minus 2 and 3 squared. This becomes x plus 3 squared. This becomes y minus 2 squared, and this becomes 9. And this is the standard form. We're going to keep it as a standard form here, everybody. Again, pretty straightforward, everyone. We are going to move on. Find the center and radius of the circle and draw the graph. All right, the center, compare it. This should be x minus h. So minus h is 2. That means this is negative 2. Compare it to y minus k. That means k must be 1. So it is centered at negative 2, 1. So 2 to the left, 1 up. So we have it there. R squared is 9, and therefore radius must be 3. So from the center, you go R units to the right, to the left, to the top, and to the bottom. So simply put, for this one, you add R, you get 4, you subtract R, you get negative 2. Then this one, if you add 3, you go to 1. If you subtract, you go to negative 5. This is 1, 1, everybody. So let's plot those. Put them all together. And there you have the graph. Again, pretty straightforward, everybody. Write the equation of a circle in standard form. Part A, the center is located at negative 5, 3 with the radius 4. So x minus h quantity squared plus y minus k quantity squared. We're going to replace the h with negative 5 and k with positive 3 and r with 4. This becomes x plus 5 squared. This becomes y minus 3 squared. And it becomes 16. We are done. We have a similar question. The center is different at 0, 0 with the radius equals 5. And obviously, we are going to use x squared plus y squared equals r squared. So it's x squared plus y squared equals 5 squared, which makes this 25. And we're done. Find the center and radius of the circle and draw the graph. It's not given in standard form. They want us to put this in standard form, x squared plus 8x plus y squared minus 6y plus 16. And what you do 2 things. You move this to the right because we want r squared, and you put these 2 together and these 2 together. And now you're going to complete the square. So look at this one only, never mind that one for now. This one, B is 8 divided by 2 is 4. And if you square that, you get 16. So you need to add 16 to both sides for this one. For this one, b is negative 6. Divided by 2, you get negative 3. Square it, you get 9. You need to add 9 for this one. So when we do that, this becomes x plus 4 squared. This becomes y minus 3 squared. These two cancel each other. We end up with 9. So this is the equation of a circle in standard form. That's the first thing we should notice. So this is the equation in standard form, and that's extremely important to understand. So what happens next? We are going to write the information in a manner that we can handle by writing the center and the radius first. So clearly, when we compare it to the standard form, the center is located at negative 4 and positive 3. The radius is square root of 9 or 3. And at this point, we are going to come up with 4 points. So the center is located at negative 4, 3. 1, 2, 3, 4 to the left, 1, 2, 3 above. We put them together, so somewhere here. Now, from the center, you are going to go R units, 3 units, up and down, left and right. So if I want to go left and right, okay, to the right, I end up with 6. To the left, I end up with 0. My apologies. To the left, I end up with negative 7. To the right, I end up with negative 1. Above, I get 6 here, and down, I get 0. So we have negative 4, 0. And negative 4, 6. We get minus 7, 3, and minus 1, 3. So from this one, we are moving to the left and right. We get those 2 points. We put them together, and that's a circle. Here's another example. We want to find the center, the radius, and graph the circle. Again, this is not in standard form. We are moving number 6 first. For this one, b is 2. Divided by 2, you get 1. Square it again, you get 1. For this 2, b is negative 6. Divided by 2, you get negative 3. Square it, you get 9. Which means we are going to add 1 and 9, 1 to this one, 9 to this one, 1 and 9 to the right side as well. So this will give us x plus 1 quantity squared. This will give us y minus 3 quantity squared. And the right side will give us 4 or 2 squared. So we're going to write it. I mean, if you can see the answer, so be it. If not, you can rewrite it in this format: x minus negative 1 quantity squared, y minus 3 squared, and 2 squared. You don't have to write that if you can see the center is located at negative 1, positive 3 with the radius 2. And from the center, you go 2 units to the left and right. So if you want to go to the left, you subtract 2 from this one, you get negative 3. To the right, you add 2, you get 1. If you want to go up, you add 2 to this one, you get 5. You want to go down, you subtract 2, you get 1. And now this is the center. Negative 3, 3, 1, 3. These are the 2 points. Negative 1, 5. Negative 1, 1. Put them all together, and you're done. That's the graph. Those are the pairs, everybody. All right. A small radio transmitter broadcasts in a 9-mile radius. If you drive along a straight line from a city 11 miles north of the transmitter to a second city 11 miles east of the transmitter, during how much of the drive will you pick up a signal from the transmitter? Let the transmitter be the center of a circle 0, 0 with the radius of 9 miles. This is 9, everybody. So that's what we have. Here's the center. We set it up at 0, 0. And then x squared plus y squared equals r squared makes it x squared plus y squared equals 9 squared. Now, you drive along a straight line and from a city 11 miles north. This is north. A city 11 miles north of the transmitter is somewhere here. A city 11 miles east to the right of the transmitter is here. And if we connect the two lines, the 2 points, it creates a line. This has coordinates 0, 11. This has coordinates 11, 0. And you should quickly recognize the equation of a line as y equals minus x plus 11. Class, all you have to calculate the slope, and I hope you see change in y over change in x gives you negative 1. And this is the y-intercept. So y equals minus x plus 11. I'm assuming everybody's okay with that. So you have 2 points, calculate the slope, and y equals minus x plus 11. So what do we need to find? Let's read the question one more time. During how much of the drive will you pick up a signal from the transmitter? This is the transmitter that it goes like that anywhere in the circle because it's within 9 miles. you will pick it up. If this line has no intersection, it's way outside the circle, you will never receive anything. If there's a point of intersection at that point, but if there's a portion, which is the case from this point, we're going to call it A, to this point, we call it B. So as we drive along this line, from here to here, we will receive the signal. We will receive the signal at this point. I hope it's clear to everybody as to what's going on. And so what we have to do, we have to find the coordinates for this point. The coordinates for this point, calculate the distance. To find the coordinates for these points, we have to look at where the circle and the line intersect. So we find points of intersection. To do so, x squared plus y squared is equal to 9 squared. Instead of y, if in essence, class, you have a system of equations. You have this, and you have this. So think about this. You have two equations, okay? And how do you solve this? By the substitution, you replace the y with minus x plus 11. So find the distance between points A and B. Because y is minus x plus 11, we are going to replace this. We get x squared plus negative x plus 11 squared is 9 squared. This becomes x squared minus 22x plus 121. This one and this one, they add up to 2x squared. And 9 squared is 81. You are going to take it to the other side, subtract it from 121. And basically you get 40, and you factor the 2. Please understand that we have 2x squared minus 2. See, this is x squared and x squared, 2x squared. And then minus 22x, we factor that the 2 times negative 11x. And then when you subtract 81 from 121, you get 40, which is 2 times 20. For this one, whether this number is 2 or any other number makes no difference. We are going to use the quadratic formula. X is minus b plus minus a squared of b squared minus 4ac over 2a, where a is 1, b is negative 11, c is 20. Plug it into this. So minus 11 becomes 11, plus minus squared of b, negative 11 quantity squared, minus 4 times a, which is 1, times c, which is 21. This is 121. This is 80. So we get 41. And this is 2. So 11 plus minus the square root of 41 plus this is 121. This is 80. I can write underneath. And so you take a square root of 41, and then you add it to 11, you divide by 2. You take the square root of 41, subtract it from 11, you divide by 2, and they give us these two numbers. Now you go back to this one. It's easier to go to this one. Y, so those are two different x coordinates. When x is 8.7 and you put it here, you have to add to 11 to give you y. When it's 2.3 minus 2.3 plus 11 gives you y, and it actually gives you 2.3 and 8.7. That means we have the points A has coordinates 2.3 and 8.7, and B has coordinates 8.7 and 2.3. So I hope it's clear to everybody. And so we want to find the distance between these 2 points. Here's the distance formula. Square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. So 8.7 minus 2.3 quantity squared plus 2.3 minus 8.7 quantity squared. And you square this, you add them up, you get 81.92, and you take a root of that, you get 9.05 miles. So the distance between these 2 points A and B is about 9 miles or 9.05 miles. So that's when the signal is covered for how much of the trip? 9.05 miles.